Hi everyone, let's solve this problem from the 1969 International Mathematical Olympiad. Prove that there are infinitely many natural numbers a with the following property. The number z equals n to the fourth plus a is not a prime number for any natural number n. Pause the video, give it a try. Okay, if you've seen our previous video, which is linked in the description, then you've had a big hint as to how you might solve this. Okay, turns out that if a is equal to 4k to the fourth, where k is an integer greater than 1, then we have the following. Z is equal to n to the fourth plus 4k to the fourth. And that expression looks familiar to those who know the Sophie Germain identity. This can be factored. And the way we factor it is by completing the square. And what we're going to do is add 4n squared k squared to the expression and subtract 4n squared k squared. Then the first three terms factor into a perfect square like this, and the last term can be written as 2nk all squared. So now we have a difference of squares, and it factors into n squared plus 2nk plus 2k squared times n squared minus 2nk plus 2k squared. So it seems we've successfully factored the number z, which means that it's not prime, it's composite. Well, that's only true if we can verify that both factors are integers greater than 1. Well, certainly the first factor is an integer greater than 1 because we're choosing k to be an integer greater than 1. And that's greater than 1 for all natural numbers n. Okay, so we just need to look at the second factor, n squared minus 2nk plus 2k squared. Well, that can be written as n squared minus 2nk plus k squared plus k squared. And we can factor the first three terms as a perfect square, n minus k all squared. So we have a sum of squares, and since k is an integer greater than 1, then this is greater than 1 for all natural numbers n as well. So that shows that z is indeed composite whenever a has the form 4k to the fourth, where k is greater than 1. And we had to show that there were infinitely many a that cause z to be not prime, and there are infinitely many numbers of the form 4k to the fourth. So we've solved the problem. Thanks for watching the video.